Good evening, my YouTube viewers. It is Crystal here. I'm just here this evening because I want to do a code review for you. Basically, I'm studying TensorFlow, and so I wanted to use a data set that I could do with TensorFlow. And basically, what I wanted was a multi-label classification data set. This isn't exactly what I wanted, but I decided to go ahead and do it anyway. So what you're going to be looking at is a data set from the Kaggle website, and it's going to be synthetic multi-label classification data set. So the first thing that we'll do is we're going to cover the problem statement. This data set is a simulation-generated data set intended to represent zip code data. This data set is a great introduction to multi-class classification tasks. Check it out. Simulation is an excellent way to augment or generate data sets. If you know the distribution of the picture you're trying to collect data on, you can use random generation, continuous or discrete simulations, and or Monte Carlo simulations to generate a data set for your machine learning model. I will continue to provide more simulated data sets, so stay tuned. And he says, let me know what you think in the comment section. So I did actually leave a comment saying it's a good data set since he wanted to know what we thought. So I created this program in Kaggle's free online Jupyter notebook, and I called it zipcode TFANN. So the first thing that you want to do is you want to import the libraries. So we're going to import NumPy as NP, which creates NumPy arrays and also does numerical computations. We're going to import pandas as PD, which creates data frames in series and performs data processing. We're going to create import OS, which goes into the operating system. We're going to import matplotlib.pyplot as PLT, which visualizes the data. And we're going to import Seaborn as SNS, which visualizes the data statistically. We're also going to import sklearn functions, which provides machine learning. And we're going to import TensorFlow and Keras down the line. So after we have imported the libraries that we're going to need to execute the program, what we're going to do is we're going to use OS to actually get the files. And there's two files, a train and a test file. We don't have a sample submission because we're not going to be submitting this to Kaggle for scoring. Then we're going to read the files using pandas. And it doesn't have a header, and because it doesn't have a header, each column is just numbered. And so the last column number 16, is your label. So that's train. And then we check for null values. We don't have any null values, so we don't have anything to impute, so that's good. Then we're going to check info, and you can see all of the columns are either integers or floats, so they're numeric, so that's good. Then we look at test, and on test is exactly the same as train, and it also has labels as well. So we look for any null values. We don't have any null values, so we don't have anything that we need to impute. We look at the info, and we can see it's all either integers or floats, so that's good, so it's numeric. Now what we're going to do is we're going to combine the train and the test set. So combi equals train.append test. So you've got combi, so now you've got test attached to the back of train, so you've got 6,000 rows. Check the shape, you've got 6,000 rows by 17 columns. Now we're going to analyze compi, and we're going to use Seaborn to create a histogram of that, and this is what we've got. So you've got 10 values, and they're all the same. we do value counts on COM-B, and you can see you've got 10 values of 600 each. Now what we're going to do is we're going to create a heat map. So core equals COM-B.core and then SNS.heatmapCore. So we created a heat map so you can see that the features are not very highly correlated, fortunately. So if you want to see the correlation, we've got core, and this will show you the correlation that each column has to each other. And now what we're going to do is we're going to define our X and our Y value. Y is COM-B pop 16, so that's the last column, and X is COM-B. So you can see that Y is 6,000 rows, and X is 6,000 rows by 16 columns. We check the feature len, which is x.shape1, and the feature len is 16. We check the number of classes with y.in unique, and so there's 10 classes. And then what we do is we one-hot encode y because y is a multi-label, multi-class, or multi-classification. So y_dummy equals pt.getDummies y.sType float 32 values, and you can see y_dummy. And so it's got like 10 rows of data, and it's looks like it's a NumPy array, and 10 columns of data, and each column of data represents a specific number. Now what we're going to do is we're going to use sklearn train test split to split the X and Y values up into training and test set. So X train, X val, Y train, Y val equals train test split. X, Y dummy, test size equals 0.1, random state equals 1. And then you check X train shape, X val shape, Y train shape, Y val shape. So you've got 540 rows by 16 for X train, 600 rows by 16 for X val, 5,400 for Y train, and 600 for Y val. And so now what we're going to do is we're going to we're going to insert TensorFlow. So we're going to use all of the TensorFlow modules that we're going to need to carry out the artificial neural network. And as you can see that with Kaggle, they're on TensorFlow 2.11 version, but on Google Colab, you're on TensorFlow 2.12. So what that means is potentially you use different coding for Kaggle than you would Google Colab. Now what we're going to do is we're going to normalize the data. Normalizer equals normalization, axis equals -1, normalizer.adapt, brackets NP array X train, print normalizer.mean.numpy. So what you're going to do is you're going to convert it to a NumPy array, and this is the values for normalized columns for X train. So now what we're going to do is we're going to, just as an exercise, we're going to check the first row of X train, and you're going to see what the first row of X train looks like normal, just before it's normalized, and then you're going to see what the first row of X train looks like after it's been normalized. Now what we're going to do is we're going to create our artificial neural network, and we're going to create a sequential artificial neural network. So model equals sequential, model.add normalizer, model.add dense 100, input dim equals feature len, activation equals reglue, model.add dense 100, activation equals reglue, model.add dense 100, activation equals ReLU, model.addEndents, num classes, which is 10, and activation, which is softmax, which is what you have to use when it's a multi-classification problem. And now you do model.summary, so you get a summary of the model. So now what we're going to do is we're going to compile our data. So optimizer equals atom, loss equals categorical cross entropy, metrics equals accuracy. And then so now we set up for early stopping equals early stopping, monitor equals valve loss, mode equals min, patience equals 25, verbose equals 1, and MC equals model checkpoint, best model.h5, monitor equals valve loss, mode equals min, save best only equals true. And now we're going to train the data. So history equals model.fit, xtrain, ytrain, epochs equals 100, validation data equals xval, yval, batch equals 32, callbacks equals early stopping, and MC. And then so we go down training it through the 100 epochs, but we've got it set up for early stopping. So it stops at 35. So results equals model.evaluate, xval, yval, and you get 95% accuracy with that. And then we plot a little graph to check what the loss and the accuracy is. So you can see the red and the amber is the accuracy and the val accuracy, and the green and the blue is the loss and the val loss. So you can see that the val loss it stays pretty consistent, whereas the loss continues to decrease. And you can see the accuracy stays pretty consistent for both the xtrain and the val. So now we're going to check ypred. Ypred equals model.predict xval, and then you can see what ypred is. So it's an array that has 10 columns to it. So ypred equals np.argmax, model.predict xval, axis equals -1. You have to do that for a multi-class. Ypred equals ypred flatten, and then ypred. So you can see what ypred is now that I have flattened it. So now what we check is the counts. Unique counts equals np unique, ypred, return counts equals true, print, dict, zip, unique counts, and you can see that each number has its own numbers, value counts. So now what we do is we check yval1 equals np.argmax, yval axis equals -1, yval1 equals yval1 flatten, and you can see yval1 here. So you've got a bunch of zeros in there as well, which is interesting because we've got some zeros in here, but when we come over here to the labels, there's not any zeros in the labels. There's not any zeros in the labels. But you can see here that you've got zeros. And 0 to 9. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So that doesn't look very good. And then we check our accuracy. Our accuracy is 95%. And now we do a confusion matrix. You can see the confusion matrix as well. And then we make a data frame and we compare the data frame against the predicted values. So you can see that that is correct. But it says right here, it says actual value equals 0. And so that's not really true because over here, we don't have any zeros in our actual values, do we? So we don't have any zeros in our actual values. There's not any zeros. So that's something that's I'm going to have to look into to make sure that this is corrected, because obviously it gives us a 95% accuracy, but obviously there's zeros in there and there shouldn't be zeros in there. So that's something that I need to look into. So, it's really good that I do these code reviews, because when I do the code reviews, it gives me a chance to look at the code and find any discrepancies and try to correct those discrepancies before I make a blog post on it. So obviously there's a discrepancy in here. There are zeros in there, and there shouldn't be any zeros. So that's something I'm going to have to correct. So thank you so much for going over this code review for me, with me, and I'm going to go ahead and correct this, so to make sure that there's not any zeros in there. And if you like my video, please like, subscribe, and share. And thank you to my subscribers for supporting my channel. And thank you again for watching this code review. I'm going to correct the error that's in it, and make more code reviews for you in the future.